Good morning everyone, I am Christine Emma Brenica and this is our report. Our topic for today is about relationship of central angle, inscribed angle, and intercepted arc. Before we start, we must know the meaning of these. So, what is the central angle, inscribed angle, and intercepted arc? Central angle. It is an angle with its vertex at the center of the circle. The sides are the radii of the circle, so this is an example of a central angle. Inscribed angle. It is the angle formed in the interior of a circle when two chords intersect on the circle. It can also be defined as the angle subtended at a point on the circle by two given points on the circle. This is an example of a central angle. Intercepted arc. It is a point at which the curve intersects the axis. The relationship between the intercepted arc and the inscribed angle is that the intercepted arc can be found inside the inscribed angle. It is also the same with the central angle. The intercepted arc can also be found inside the central angle. In this picture, we can see an example of the inscribed angle, and the red line here is the intercepted arc. In here, we can also see an example of the central angle, and the red line here is the intercepted arc. So now that we know what is the relationship between the central angle, inscribed angle, and the intercepted arc, let us move on to the next. What is the relationship between the central angle and the inscribed angle? Both have the same measure, meaning the measure of the central angle is the same measure of the intercepted arc. A central angle and an inscribed angle intercept the same arc. The central angle would be double the inscribed angle. The inscribed angle is half of the central angle. Here is an example of the central angle with the inscribed angle and its arc. The next reporter is Sheena Alier.
Right triangle inscribed in a circle. The hypotenuse of a triangle inscribed in a circle coincides with the diameter of the circle. We can also say that an angle inscribed in a semicircle is a right angle. From the figure on your screen right now, the diameter AC is the hypotenuse of triangles AB1C, AB2C, AB3C, and AB4C. So here is a proof showing that a triangle inscribed in a circle having a diameter as on one side is a right triangle. So first we're going to draw our figure, which is the circle. Now I'm going to add the center of the circle in here. Now I'm going to add the diameter. So this is our diameter. So since we're going to make a triangle in this circle, we're going to add a vertex or the corner of a triangle, and I'm going to put it right over here. Draw that out, connect that, and we have a triangle. Now let's say this is our inscribed angle, and we'll call it theta. This is the symbol of theta. So now we're going to divide this. So we're going to connect vertex and the center of the circle, like so. Now, when you look closely at this, since it is already divided, you could really see that there are three radius. We have radius 1, 2, and 3. So this angle here, this inscribed angle, subtends this arc up here. We'll highlight that here, this arc up here. This is the central angle. And this central angle subtends the same arc. So it will have twice this angle. So twice this angle will have 2 theta. There. This angle here with 2 theta is an isosceles triangle because when we rotate that, here we go, like this, like so. This is what it looks like when we rotate it, right? It has an equal sides. So which means our base angle needs to be equal as well. So we're going to use x for that. I'm going to write it over here. All right. Now, the question here is, what is x going to be equal to? So, x plus 2 theta have to equal to 180 degrees since it is an isosceles triangle. So we're going to write it down. X plus 2 theta equals 180 degrees. X plus x equals 2x plus 2 theta equals 180 degrees. 2x equals 180 degrees minus 2 theta. We're going to divide that into 2. And the answer will be x equals 90 degrees minus theta. And we're going to write it down here as well. Now let's see the other triangle over here. It has radius on both sides, which means this is also an isosceles triangle. And an isosceles triangle needs to have an equal baseline as well. Base angle. Sorry. So this is our angle. So we're going to put theta as well, since it is the angle. So what is this whole angle right over here? Here. What is this whole angle over here? So it will be theta plus 90 degrees minus theta. Now we're going to cancel out the theta. So 90 degrees will be left behind. So no matter what, as long as one side of a triangle is a diameter, and then the angle or the vertex is on the circumference, then this angle right over here is going to be right angle. And this is going to be right triangle. So let's say I'm going to put a random vertex. I'm going to put the vertex here. Draw that out, connect that. So it is a right triangle. Now let's move on to the next topic.
So here is our example. This is example 1. So as you can see, we will need to find x, and to find x, we will apply the theorem. The theorem is a times b. This is the theorem. Is equals to x times y. This is the theorem. So to apply this theorem, we'll do 3 times 10 equals to x times 6. So 3 times 10 equals to 30, and x times 6 equals to 6x. So in order to solve for this, you need to divide it by just 6. So 6 times 6 is 1, 5. This equals to x. So this is 5. So this is 5.
Intersecting secant. First is to find the formula, and second is looking at example. As a reminder, all secant is a line that goes through the circle and hits the circle at 2 points. Notice this line hits the circle, and that's all secant is. When we have an intersecting secant, there's actually a theorem we can use to factor any missing length. The theorem states that line AB times AC is equals to AD times AE. Notice that this is over here. Let's see how we can apply this theorem to a question. So we have our question given AZ is equals to 4, AE equals 2, and BC equals 10, and find the value of AB.
This x right here is the missing value. Before we do anything, let's try out our intersecting secant theorem formula. We have AB times AC equals AD equals times AE. So what we are gonna do here is just to fill our formula. AB equals x times x plus 10 equals 4 times 4 plus 2 is equals to 6. X squared, and use the distributive property, which is x times x is equals to x squared plus x times 10 is equals to 10x equals 4 times 6 equals to 24. X squared plus 10x minus 24 equals, and to factor, I like
So, good morning everyone. My name is Erwazaneb Bajungan, and I'll be talking about intersecting tangents and secants. So, the theorem is a squared equals x times x plus y, or the square of the tangent is equal to the outside part of secant times the whole secant. So here, we're looking for x and we have x as tangent, so we do x squared equals 9 times, and then the length of the whole secant is 9 plus 3. So we do that problem, and then the x, and we find the x is equals to 6 root 3. So we'll just do the same thing before. So 12 equals 6 times